So hello guys, today we are going to do the daily lead code problem, special position in a binary matrix. The problem states that we have given a matrix of m cross n size, and in which the zeros and ones are present. We have to calculate the special count of total number of special positions in a matrix, but there is a condition for the special position. Okay, the condition is that a cell is said to be special position if all the elements in its rows and all the element in its column are to be zero, has to be zero. Okay, if this condition satisfied, then it is our special position. Okay, so we will store increment our answer by 1 if this condition met. Okay, this is the problem saying. So let us see the first example. In this, we see that there are three ones are present. If we check on the first one, this one, and here we see that another one present in the column, and so it will not be our answer. We will ignore it. And if we check this one, so if we go and check the rows and columns of this one, we see that only zeros are present in. So it will be our answer, and we will increment our answer by 1. And if we check this, this is also failing as one is also already present in it. Okay, so it will not be our answer. So overall output will be 1. Okay, and as an example 2, we have given this matrix, and in this there are three ones are present and all three ones are satisfying the condition, like whole row is 0, whole column is 0, whole row is 0, whole column is 0, except the cell for which we are trying. Okay, so the output of this is 3. So now let us see the constants. The constants are m comma n, the value of like or n can goes up to 100. Okay, and the matrix of I, the value in the cell can be present is 0 or 1. Okay, that's great. So what I'm thinking is we will take two vector of the row size and the column size, and store the all the ones present in the row, and store all the uh, ones present in the column in the vector. And then we will iterate on the matrix, and we will check, and like we will check on the cell which whose value is 1. If the value of cell is 1, then we will check in the row and column vector, where like the row and column vector should also be 1. Okay, if the count of ones in the row and column vector will be greater than 1, then it will not be our special position. Okay, so yeah, this is our approach, and uh, for with this we will be getting all the count of the ones special positions. So let us dry run it on our example. Suppose uh, we will be taking in this we will be taking one row vector which will be storing the count of ones present in a row, like this is a row of 0, row of 1, row of 2. Okay, how, so this will look like this. Okay, and if we check in row of 0, there is only one present, 1 is present, and in row of 1, uh, 1 is present, in row of 2, 1 is present. Okay, and we will also be taking column which is storing the count of ones present in column, each column. Okay, so column of 0, there are 2 ones present, and in column of 1, 0 ones present, and in column of 2, 1 present. Okay, this is how our row and column will look like this. Correct, and let's also do the indexing of this. So the indexing looks like 0, 1, 2. This is our indexing looks like for this, and after that we will be traversing on the matrix. uh, one loop will be going from I equal to 0 to n, matrix like, and j we will be also taking. Let us first write this I equal to length of the matrix. So matrix dot size, and j will be the length of the each row. Okay, so this will have I and j are. Okay, so one loop will be going from I equal to 0 to n, and another loop will be going from j equal to 0 to m. Got it? And if we see any cell whose value is 1, okay, if whose value is 1, if like matrix of I comma j equal to 1, if the value of the cell is 1, then we will check in our row and column vector whether the value of row and column vector at ith and jth index is also 1. If that is also 1, then yes, it will be our element which is a special position, and we are looking for this, so we will increment our count by 1. If this is equal to 1 and row of I equal to 1 and col of j equal to 1, if this condition satisfy, then we will increment our count by 1. Okay, and this will how our approach will look like this. And for this cell, while we come in this cell, it will fail the condition as, let us as the let's dry run it. Okay, so for the first one, it is like matrix of 0 comma 0. Okay, so we will go on the 0th, we will look on the 0th position value of the row, so it is 1. And we will also look in the 0th position for the value of column, it is 2, so it is not satisfying our condition, we will ignore it. Okay, and if we come on this uh, matrix of 1 comma 2, so here we will check the value of row at ith index, it is 1. Okay, and value of column at jth index, it is 1 also. Okay, so this will now we will increment our count by 1, count plus plus. Okay, so our count we will look count equal to 1, it looks like this. And if we come at this one, so it is matrix of 2 comma 0, and we see that the we will check the row value at the row of 2 index, and it is 1 here, and value of column at 0th index, it is 2, so it is also not satisfying our condition, we will ignore it. And at the end our result will looks equal to 1. Okay, so we will return 1, and let's try run it on this example too also. So let's copy it down here. So if we store the count of all the ones present in row and column, it looks like uh, the total number of ones present in 0th row, it is 1. Okay, in this also 1, in this, and same for the column, it is 1 1 1. Okay, now we go on the first cell, matrix of 0 comma 0, it is 1, and we will check the whether the value at the 0th index in row and column is also 1, then we will increment our count, and here it is actually 1, so our count will be count plus equal to 1. And if we come at matrix of 1 1, again we check this and we will find this same condition, we will increment our count to plus 1, and at here, matrix at 2 comma 2, we will get the all the satisfying condition and increment our count by 1. Okay, and at the end our answer count will be becoming 3, which is our output. Great. Now let's code this approach. So int n equal to, we will be taking the size of the matrix, and well m equal to length of the row, it will be, and also we'll be taking into vector row for restoring the all the ones present in each row, and vector column for restoring the all the ones present in each column, and then we will iterate on matrix j equal to 0, j less than m, j plus plus, and what we will do, okay, we will if we see that the, if we will see matrix of I comma j equal to 1, then we will increase the row value to +1 and column at ith to +1. Okay, now here after this, after storing the count of all the ones, we will be taking one count variable to store a, which will be returning our answer. Now again we will be iterating on the matrix for int j equal to 0, say j less than m, j plus plus. If the value of matrix at ith and jth equal to 1, and row at I equal to 1, and column at j equal to 1, then we will increment our count by 1. Okay, and at last we will be returning the count. Let's run it. I think there is typo mistake. Some. If matrix of I comma j 3, okay, I hope it will run. One error is coming, let me debug it. This is 3. Okay, so we are taking on row, column. Okay, and we will be traversing on the matrix and storing. If matrix of this, then suppose when we come at here, so when we come at here, so column of j p plus plus, and okay, here we have to write column at j. Great, let's run it. Yeah, all test cases are passing. Let's submit the code. Great, it is submitted. Now let's check the time complexity. So we are taking 2 vector for storing our answer. So space complexity will be m plus n, and time complexity will be, we are traversing twice, and it will be like m cross n, order of m cross n. Okay. Okay, great.